Today's activity is going to be called Down by the Bay. So you're going to be designing a swimming area at a local beach. So what I want to just kind of stress first is that we're looking at three-sided rectangles today. So I mean, you might say, well, a three-sided rectangle doesn't really make a rectangle. If it's shaped like this, that doesn't really make a rectangle because don't you need a polygon to be closed? In our case, it's going to be okay to have this open three-sided rectangle. Imagine that this is a fence and you're looking at it from above, and this is your house, for example. That could be a house that's built there. So maybe you do build this rectangle that only has three sides if you're putting up a fence. It'd be kind of weird to put a fence right along the side of the house. So three-sided rectangles, it's kind of interesting. That's what we're going to look at today. So what you have to do is you imagine that there's a beach. So here's a beach, and there's people. Here's some towels on the beach. Oh my gosh, I'm going to draw. Here's a ball. Here's a beach chair. Oh yeah, here's my person. There you go. There's my person, and they're happy because they're at the beach. This is the beach, and I'm sure you've all been to the beach. And the lifeguards in the summer, at the beginning of the summer, they put out a buoy line that looks like this. So your task is going to be something like this. What if that was, you had 60 meters of rope? So you're a lifeguard and you go to the lifeguard shed and you come out with 60 meters of rope, and that's what you have. So how many different swimming areas could you make? 60, if I divide that by 3, I get 20. So one area, I could take my rope, if the beach is along here, I don't really need to put the buoy line across the beach because you don't typically step over the buoy line to get into the water. Maybe it's just going like this. So we have 20 on this side and 20 on this side and 20 on this side. Okay, so that 20, 40, 60, that's your 60 meters. That would use up all the rope. Another thing we could do for 60 meters, oh, you have lots of choices. What if this side was 10 and this side was 40? Does that make sense? If this is 40 and this is 10 and this is 10, does that give you 60? So 10 plus 40 plus 10 is 60. So there's another one. And this is the beach along this side where you don't need a fourth side for your rectangle. What else? We could do a bunch, right? If it was 60 meters, we could do a few of these. What if one side was a little longer this way? What if this side was 30? So the one interesting thing you have to notice is that there's one side that is one value, 40 for example. The other two sides have to be the same, and there are two sides that are the same. So if this side was 30 and then I have to make up 60, I'd have another 15 and 15 because that would make up 60 altogether. So I'm coming up with some different options, and just like the fence Fido-In sheet, you're going to have to look at the area of these shapes. So for this, in this case, when I just divided by 3, that would have been 20 times 20, and 20 times 20 I know is 400. So the area of that shape for the swimmers would be 400 square meters. If I did 10 times 40, I get 400. Oh, so this is going to be the same. And this one, if I do length times width, then I do 15 times 30. Oh, this one, I actually get an area of 450. So this one's bigger. I have more area for the swimmers in here. So you're going to be this lifeguard, and you're going to imagine that you're going to tell the other lifeguards, well, I know exactly mathematically how to set the rope into the water to give me the most area, because that would be the best thing, right? You only have so much rope. You can't go buy a new rope. So you're going to want to have the biggest area for the people swimming that you can. So your activity today is down by the bay. You have 100 meters of rope. So that's different. It's not 60, it's 100. So here's an example. This is the beach along this side here. That's the beach. We don't need the rectangle to go along that side. But this would add up to 100, right? We have 90, 5, and 5. So that would add up to 100. And we know area is just the length times the width, just one of each, length times width. So the area of that shape is 450. It's asking you to sketch some other ideas that would come up to having a perimeter of 100 meters, but remember, your shapes can only have 3 sides. Predict the greatest area, and then here, if we had perimeter, notice the perimeter is always the same now. If the width was 5, then the length would have been 90. So they did this one for us already, and the area is 450. So you're going to have to come up with a few different possibilities, and just switching the 90 and the 5 won't work, because imagine if you had 90 and 90 and 5, that is not going to add up to 100. So that's not going to work. You're going to have to come up with different possibilities, and you get 100 meters when you add the 3 sides together. And then there are some questions on the back about what would actually give you the largest area.